Hi, boys and girls. How's it going? Here we are on Chapter 9, Lesson 5, and this is called Problem Solving Money. Mo money, mo problems. Now, that's just for adults. All right, there you go. So, all of these problems are going to be about money. And talk about math in your real life. You are always going to deal with math when you deal with money. They just go hand in hand. So if that's not inspiration for you to learn math, I don't know what is, right? Money. Okay, so here we go. Number 3. Marcus, Nan, and Olive each have $1.65 in their pockets. They decide to combine the money. How much money do they have all together? All right, so let's see here. Marcus, Nan, and Olive. All right, each of them has $1.65 in their pockets, and they decide to combine their money. All right, so let's do $1.65, $1.65, $1.65. Let's add them up. Okay, right? So here's Marcus, Nan, and Olive. Let's see how much money they have together. So we're adding. So we have to go down the ones, ones place first, of course. 5, 10, 15. Regrouping the 1, 5 down there. And then 6, 6, 6. What's 3 sets of 6? 6, 12, 18. Plus this guy up here is 19. 1. And then the 9. More regrouping. Now, it's important, guys, we have a decimal. Boink. In addition, you bring the decimal straight down into the sum. And you line it up before you start adding too. Okay, keeping those place values in line. All right, now let's do the whole dollars. They have 1, 2, 3, and this guy, $4. So how much money do they have all together? They have, put the dollar sign, $4.95. All right, I wonder what they're going to buy. Okay, let's keep going, guys. Number 4, Jessie saves $6 each week. In how many weeks will she have saved at least $50? So guys, they're saying at least $50 because it doesn't have to be exactly $50. It has to be at least 50. So it can be 50, 51, 52, 53, right? Okay, so let's see how we're going to solve this one. She saves $6 each week. So in how many weeks will she have at least $50? Well, let's see. If she saves $6 for, you know what, I'm going to start with a friendly number. I'm going to say $6 for 10 weeks. Okay? She'll have 10 sets of $6. Okay, so I'm just like using a try, check, and revise kind of a thing. So $6 for 10 weeks, that would be $60. Well, that's pretty close to 50, but I have a feeling that there's something lower than that, right? So let's go down 1 week. So $6 for 9 weeks. Okay, so let's see, 6 times 9, you're using your nines trick, put down your 6th finger. 54. Ooh, that's very close to 50, isn't it? So in 9 weeks, she saved $54. Now, if we go down one more, 6 times 8, well, 5 times 8 is 40, 6 times 8 is 48. Nope, that's not at least 50, is it? Okay, so you see I started with a friendly number, and I thought, oh, that must be it. But then I did one more just to check myself. Okay, so she saved for 9 weeks. That's awesome. She saved, oh my goodness, look at my writing. She saved $54 in 9 weeks. That's pretty good. All right, let's keep going, guys. This is on the back, the lesson check. Okay? It says, which represents the value of one $1 bill and 5 quarters. Okay? So she's got, no, it's not even a person in this one. It's just a regular question. So we have here a dollar, right? A $1 bill. Pretend George Washington is on there. And then 5 quarters. Okay, 5 quarters. What is a quarter? How many cents in a quarter? A quarter. Remember a quarter of a dollar? Okay, we have 5 sets of 25, right? So what's 5 cents of 25? Well, should we do this? 25 times 5. 25. Well, that's 125 cents. 125 cents. I got to think about that. What do we know about 100 cents? Or another way you could think about it is, what do we know about 4 quarters? We could have broken apart 5 into 4 plus 1, right? Because what do we know about 4 quarters? 4 times 25 is 100, right? So 100 of those cents is another dollar. And then, of course, 1 times 25 is 25, which is this other part here, right? So 125 cents is basically 100, which is another dollar, boop, and 25 cents. Okay, so what do we have, guys? We have $2.25. Yeah, there you go. We're not going to let that 5 quarters throw us off. Okay, now to chapter 5. Oh my goodness, chapter 5. That was so long ago. Let's read this. I am a prime number between 30 and 40. Which number could I be? Okay, a prime number between 30 and 40. Do you guys remember those divisibility rules? Those are so helpful, guys. So right now I'm going to write 31, 32. Why am I writing these? Because they're all our answer choices, basically. It's between 30 and 40, so it can't be 30 or 40, right? 39. Did I get all 31, 32, 33, 34, 35, 36, 37, 38? Okay, so a prime number, guys, remember, is a number that has only 2 factors, right? A prime number only has 2 factors, and the factors are 1 and the number itself. Okay, so for example, 3 is a prime number because the only way to get 3 with whole numbers is 1 times 3. Okay, so we got to look at these numbers in the 30s. What I'm going to do is eliminate some that I know are not prime numbers from what I know about divisibility. I know that any number that's even is divisible by 2. Because if you have an even number, you can divide that into 2 equal parts. Okay? If I have 32 cookies, I can share them, 16 for you, 16 for me. Okay, so I'm going to cross out 32. Where are the other even numbers? 34, 36, 38. Farewell, even numbers. That narrows it down, doesn't it? I also know the divisibility rule for 5. If a number ends in 5, it is divisible by 5, right? 5 or 0, actually. Okay, so goodbye, 35. You're not prime because I know 7 times 5 is 35. All right? So let's see. We have 31, 33, 37, and 39. Okay, so 31. I'm thinking of factors. Nothing pops into my head for 31 as factors. Let's keep going down the row. Oh, now 33. I know the divisibility rule for 6. Do you guys remember that one? That's a great divisibility rule. The divisibility, not for 6, for 3. Did I say 6? The divisibility rule for 3. A number is divisible by 3 if you add the digits, 3 plus 3, right? I added the 2 digits is 6. If I add the digits of the number and that sum is divisible by 3, then the whole number is divisible by 3. So 3 plus 3 is 6. Is 6 divisible by 3? Absolutely. 6 divided by 3 is 2, which means 33 is divisible by 3, so it is not a prime number. All right, 37. Now, so I'm going to add these digits. Let me think here. 3 plus 7 equals 10. Now, 10's not divisible by 3, is it? All right, I'm going to jump to 39. Let's look at 39. 39. Let's try to add those digits. 3 plus 9 equals 9, 10, 11, 12. So remember, if it's divisible, if the sum's divisible by 3, then the whole number is divisible by 3. Is 12 divisible by 3? It certainly is. So that means 39 is divisible by 3. Goodbye. All right, I'm thinking about 31 and 37. And you know what? I'm going to look at my answer choices now because I have a feeling those are both prime. A, 31. B, 33. We already eliminated you. C, 30. Oh, we eliminated 36 because it's even. D, 39. We eliminated 39 because of the divisibility rule for 3. So, hello A, 31. Okay? 31. Beautiful. You guys killed it. And you know what? I think 37 is prime also, but that's not one of the choices, is it? I always have to pause on prime numbers and really but I think 37 is prime too. All right, wonderful children. Have a great night, and I'll see you soon.